Welcome back, learners. Now let us look at some activities, okay? Some activities from previous question papers. And as always, we are going to be starting with the multiple choice question. Let's look at 1.1. Says to us, inertia of an object is best described by Newton's. Okay, it is normally Newton's first law. Well done, guys. Why Newton's first law? Because inertia describes an object resistance to a change in the state of motion. So for the moment there is a resistance in the state of motion, which is Newton's first law, then we know that we always associate inertia with Newton's first law. 1.2 says an object resists a change in a state of motion or rest because of, I'm sure you were listening just now. Yes, well done, because of inertia. So B will be the correct answer for you. Let's quickly move on to the next multiple choice question. 1.3 says to us, the block with a mass of 20 kg in the diagram below moves towards east at a constant velocity across a rough, okay? The moment you see rough horizontal surface, what comes into your mind? We need to have what? Friction. Friction is there. F. Friction is there, okay? Very important. A block of mass 20 kg in the diagram below moves towards east. East goes to the right hand side, okay? Then they say the velocity is constant because if we have constant velocity, what does that mean? We know that F net is equals to 0. Why F net is equals to 0? Because acceleration is 0 meters per second squared. So which one will be most correct answer? We know the one that talks about 9,8 is out. 9,8 is out. So our answer must lie between B and what? And D. So the most correct answer will be what? Will be D. Why is D the most correct answer? Because if the object is moving at constant acceleration or constant velocity, it means that the force applied, the component of the force applied will be equal to the friction force. Here, B is incorrect because we are saying that the force applied will be less than the friction force. And normally when the force applied is less than the friction force, that means the object will not be able to do what? To move. Okay, let's quickly go to the next multiple choice question. It says the diagram below shows the forces acting on a box rather. There is our box. We have the normal force, we have weight to F, force F. Then they say to us, which one of the following equation is correct for the magnitude of the normal force? Remember, we said when we have an angle, we know that the normal force does not only equals to Fg, but it also has the component of what? Of F, because F is acting at an angle, we need to include the component which is Fy sine theta, and this one will be Fx cos theta. So which one will be the correct answer? The normal force and F sine theta are in the same direction, while weight is in the opposite direction. So what will be the normal force equals to? The normal force will be equal to the weight minus F sine theta. So A will be the correct answer. Now let's look at why B is not correct. B is not correct because it's saying that the weight and the F sine theta rather, which is the component of F, they are in the same direction. As we can see, they are not in the same direction. F sine theta is going upwards and W, which is weight, is going where? Downwards. So this one is incorrect because of it. Let's quickly look at C. C is incorrect because it tells us about the cos, and we know that when we are looking at the angle from the horizontal, your X component will be cos, not your Y component. Now remember, we are looking at the vertical axis, so we are dealing with the sine theta. So over here, D, why is it incorrect? Also, it's the same thing because of the cos theta. All right, guys, I hope you are with me and we are getting all these answers correct. Now that we have looked at some multiple choice questions, let's quickly rush into the long structured questions as the exam might look like. Now we look at question 3.1 says to us, a crate of mass 2 kg is pulled to the right across a rough horizontal surface. I hope you are writing something there once you see rough, by a constant force F. Remember, what is constant here is the force, it's not the acceleration. All right, very important. Force F is applied at an angle of 20 degrees to the horizontal as shown in the diagram below. Here is your diagram. We have the block of 2 kg We have the angle at 20 degrees. You also have force F that is acting at that particular angle. The first question 3.1.1 says, draw a labeled free body diagram showing all the forces acting on the crate. Remember, how do we draw the free body diagram? We represent the object with a dot. Which force must you start with? The force that is always guaranteed. Which force is that one? Is weight or gravity, force of gravity rather. And then, which other force is there? The given force that you have given here. Remember, you just draw it as it is without the components. You're going to draw force F, which is that force applied that is acting at an angle. Then nextly, what are you going to do? You're going to draw the normal force, okay? Very important. The normal force. Please, you don't put so many lines that I'm putting here. It's just that my pen is giving me a problem. So please, you put the normal force acting perpendicular to the surface. And then lastly, what is it that I'm going to put? If you are not sure if you must put friction or not, we said we must look at the mark allocation. The mark allocation is going to assist us to know how many forces must we draw, because each force is 1 mark. So I already draw 3 forces here. That means the next force that I have to draw is the friction force, okay? Which is small letter F, all right? Which is that friction force. So that is how you draw the free body diagram. Those are all the forces that are acting on the object. Why is my friction force going to the left hand side? Because the force applied is going to the right hand side and the object is accelerating to the right. Okay, very important to know that. Now guys, now that we did 3.1 together, I'm just quickly going to give you just 3 minutes to try to do this question alone, and let's see if we can get it right. Okay, welcome back learners. Let us quickly check if you have done it correctly, and let's see how we arrived at the answer. We still have the same statement that we were given in the previous slide. We just have to go straight to what the next statement is saying. A constant friction force of 3 Newton acts on the crate. So here we have a friction force over here. Our friction force, which is how much? Is equals to 3 Newtons. So sometimes it's very important to collect the data on the statement itself. The coefficient of kinetic friction, between the crate and the surface is 0.2. Please bear in mind that the coefficient of kinetic friction is not friction force. It is this funny U with that K. That is the coefficient of kinetic friction. This is the one that is equals to 0.2. But if you find yourself confused as to what is the difference between the coefficient of kinetic friction and the friction force, remember the friction force is the force, it is measured in newtons. The coefficient of kinetic friction is a ratio, it doesn't have any SI units. Very important to remember that. Calculate the magnitude of the normal force acting on the crate. I hope we were able to do that. Now look at the mark allocation. The mark allocation is going to guide you. What do you have? You have the friction force, you have collected your data, you have the coefficient of kinetic friction. So which formula are you going to use to help you to do this? You use the formula Fk is equals to the coefficient of kinetic friction multiplied by the normal force. Do you have the friction force? Yes, we were given over here, which is the 3 newtons. You substitute the 3, which will be equals to, you have the coefficient, which is 0.2. You are looking for n, okay? Then from here, you just play around your mathematics. Your normal force should be equals to 15 newtons if you have done it correctly, okay? Remember that because we are calculating the magnitude, it's not really necessary for us to include what? Direction, because the examiner was just looking for the magnitude. But if we were to include direction, we're gonna say we know that the normal force always goes where? Upwards. Okay, if they were just saying calculate the normal force, then we would know that the normal force must have magnitude and direction causes the force. Let's quickly go to 3.1.3. It says calculate the magnitude of force F. Again, you look at the mark allocation over there. Your mark allocation is 4 marks. Now, where do you want to start? Now, you look at what is it that you have. You have the normal force, you have the friction force, you have the coefficient of kinetic friction. So, which formula can help you to do that? You can use F net equals to 0. Why? Because you want to only look at the forces that are acting vertically. Why? Because those are the forces that are going to give you what you are looking for. Here we don't know how much force F is, and we don't know how are we gonna arrive at our answer if we do that, because we don't know if actually we can't use the horizontal because we don't know how much is the acceleration, and we were not being told that the object is accelerating at constant velocity. So we therefore cannot assume that the horizontal motion of the object will be equals to 0. The only one that we know that is equals to 0 is the one that is going to be acting vertically. So what is it that I have vertically? Remember, I have my normal force, I have my Fg or my weight going downwards, and then I have my friction force, I have my normal force, but do not forget the component of the F, which is F sine theta. Okay, so we will use that to calculate. So how are we going to do that? We will do it shortly. Here, let me provide space for myself. Let me try to erase some of the things here, but I know you guys got all of this correct, right? So there's no need for me to worry about if you're gonna get all the answers. I know you're gonna get all the answers. So here I'm looking for F. I have the normal force, I have Fg, which is weight, I have the friction force, which is, they gave us as 3 newtons. I have the coefficient of kinetic friction, which I was given as 0.2. What else do I have? I know the components, the x component and the y component. The x component over here is fx cos theta, while the y component is fy sin theta. Therefore, I said we're going to use the vertical components. Therefore, the vertical forces, that will be F net is equals to 0, which will be the normal force will be equals to the weight minus F sine theta. Okay, remember why the weight equals to F minus the weight minus F sine theta, because these are the ones that are acting horizontal. All right, then let's quickly put in the values. We just calculated the normal force. Remember, we got 15, so you're gonna put your 15 here is equals to weight is mg, so m is your 2, which is the mass, g is your 9.8 minus f is what I'm looking for, and then the sine of the 20 degrees that I have is equals to 0. So the moment you have all of that, what is remaining now is just to solve for f, and if you have solved for f correctly, you should get the answer as 13.45 newtons. I hope you guys got it correct. All right, I know you got it correct. Now let's quickly look at 3.1.4. How do you then calculate acceleration? Now that we are looking for acceleration, we are then going to be looking at the horizontal motion of the object. Okay, how do we do that? We still have the fx. Let me try to use a different color pen so that you can see. I have my fx, which is across the x-axis. I have my fk, which is across the x-axis. So that is all the forces that are acting across the x-axis, and that is what I'm going to be looking at. So therefore, I'll have the F net is equals to ma, where my F net will be F cos theta minus the Fk is equals to ma. What is the F cos theta? You already have the value of F, which is that 13.45, and then the cos of which angle, the 20 degrees angle, minus Fk that we were given, which is the 3, equals to the mass. Mass is 2. We are looking for the acceleration. So the moment you are able to do all of that, what is left is just for you to solve for A. And if you solved for A correctly, your A is supposed to give you 1.18. Okay, 1.18. Okay, let me write it here. Equals to 1.18 meters per second squared. Okay, remember the SI units, meters per second squared. That is what we are expecting you to know. I hope you got it right. For this one, I'd like to give you a little bit of time, so 2 minutes on top. You can try to do this on your own, and let's see if we can do it together. Now guys, let us try to do it together. Question 2 says, A trolley A with mass of 20 kg is pulled with a force of 50 newtons to the right at an angle of 30 degrees and experiences a kinetic friction force of 7,3 newtons. Trolley B with mass of 10 kg is attached to trolley A with an inelastic string and tension. Trolley B moves over a frictionless surface. Okay, right, you can see here you have two trolleys, trolley A as well as trolley B. Trolley B is at a frictionless surface. This means that there is no friction. Remember, there's no friction. Keyword. When you see kinetic friction force, that means here we do have what? Friction. Okay, we have the FK over there. Very much important to remember. Then you have force of 50 newtons acting at an angle of 30 degrees. Now 2.1 says state Newton's first law of motion in words. I know very well that you know how to state this one. So we know that it is we know how to state Newton's first law rather. So I'm not going to be stating it with you. I know you know how to do it. 2.2 says to us, draw and label a free body diagram of all the forces acting on block A. So let's quickly look at block A. Block A, we have a force over there of 50 newtons. We have weight, okay, which is Fg or weight. We also have what we call the normal force, and then over there we have the kinetic friction force. Okay, and how many marks is that one? It's 5 marks. So that tells you we have 1, 2, 3, 4. So another force is missing. Which force? It is the tension force. So let me show you how I've done it from my answers. Okay, so let's quickly go to it now. I'm going to show you how I've drawn the free body diagram. Is I have indicated the dot. I have the force of the 50 newtons acting at an angle. I have the normal force. I have Fg. I have tension. I have the friction force. That is why this was what? Was 5 marks. So I'm going to say to you, this in the past was accepted in the past. So please, this year, let us try not to draw using the component. So you only draw this only when you are using calculation. So maybe let me make a note for you. Only when doing calculations. Okay, calculations. The only one that you use when you draw the free body diagram, that is the correct one. And remember, I did say that you know how to define Newton's first law. As you can see, I know that you know that when an object continues in a state of rest or uniform velocity, unless acted upon by a net resultant force. So that is how we define what? Newton's first law. So let's quickly go back to our main question. So we were able to answer the first two questions, which 2.1 and 2.2. So we are quickly going to jump into the next question, which is question 2.3 as well as question 3.4. So again, I'm just going to give you 2 minutes to try and do it on your own. Then we'll quickly do it together. Okay, guys, let's see if we can do it together now. 2.3 says, calculate the horizontal component of the applied force on trolley A. So on trolley A, we have the 50 newtons. They want us to calculate the horizontal component. Remember, that is force F. When we break it down into components, there are two components that we are going to have, the Fx component and the Fy component. So the question wants us to calculate the horizontal component, which is Fx. So how do we do that? We say Fx, which is the horizontal component, is equals to F cos theta, Y cos, angle from the horizontal. Then we substitute how much is my force. It's 50 cos of how many degrees? 30 degrees. And you quickly punch that into the calculator, you should get 43.30 newtons. Okay, that is the magnitude, the horizontal component. But if they just say calculate the horizontal component, remember the horizontal component, it is a vector quantity. It must have magnitude and direction. So what will be the direction of your Fx? It will be to the right. As you can see, it's going to the right hand side over there, right? Very important to include that. I know this one you got it right. 2.4, calculates the magnitude of the acceleration of the trolley Acceleration now is what we are looking at. Let's quickly go to see how I have done it for you. All right, now it's very important to see how the marks will be distributed as you do this. Now, because we are calculating acceleration, one thing that we must do, step number one, I always say, draw the free body diagram of the two separately. You already have the free body diagram for trolley A, so the next thing that you would do is to draw a free body diagram for trolley B, which is the 10 kg block. Okay, so what is it that you need to do? The 10 kg block, if you draw the free body diagram, we only have what? We only have tension going to the right hand side. We have the normal force going up. We have Fg going downwards, or weight. Okay, remember this trolley, which is trolley B, did not have any friction. We were told that we must ignore what? Friction. So the only horizontal force that is acting there is tension. That's why we said F net is equals to ma here. Then we said T is equals to m multiplied by A. And then here we substituted the mass of the object, which is 10. And then we are looking for A. So what is it that we need to do? We equate T so that we can equate T in both the equations. The next thing you're going to do is go back to the 20 kg block, which is the first block that you were given, which is block A. You already have the free body diagram for it. Remember the free body diagram, we had the normal force over there. And then because now you want to see clearly the forces that will be acting, nothing is stopping you from including the components. Include the components, put your Fk, go there and put your Fg. Now remember, there is tension that is holding the two objects together. Now what is it that you are going to do? Again, you have your Fx, which is that one going to the right hand side. You have your friction force. You have your what? Your tension force. This is what sum means. But remember to include the signs. Your F and X, which is the force that you calculated in the previous question as 43,3, you substitute it there, and then you minus the friction force because the friction force goes into the opposite direction, and then your friction force, remember, we're given as 7,3 in your question, and then you also minus the tension that you are given, and then what you do, you just play around with your mathematics, and then you should get how much your acceleration is. After equating the two, you're going to say equation 1 is equals to equation 2, which means that you're going to equate that one and this one, and then when you are done doing your maths, you should get acceleration as 1,2 meters per second squared, and that's how you get your 6 marks. You have the correct formula, you get 1 mark. Correct substitution on the right hand side, another mark. Correct substitution on the left hand side is another mark. Also another mark here, and then the other mark is for the final answer. I hope you can see how the examiner has assisted you in answering the question. Now let's quickly go back. Remember, we are not done with our question. So the last question that we are left with here is to calculate the tension on the string. We have calculated the acceleration. So now we need to calculate the tension. Guys, it's very easy. You just go back, okay, not really back, but you go to the question that you just calculated where you found the acceleration. So you already found the acceleration as 1,2 meters. Then you go to either equation 1 or equation 2 to substitute and get your tension. All right. When you do that, you should get something like this. Okay, where you go and say, I'm taking F net is equals to MA. Say you are using the 10 kg block. If you are using the 10 kg block, that is the one that you're going to use. You put the mass, then the acceleration that you calculated 1,2, and then you should get 12 newtons. Now you remember that you must get the same answers. If you don't get the same answers, that means somehow your calculations was incorrect. So you can either use option 2, which is using the 10 kg block, or option 1 where you use the 20 kg block. Okay, now you go back to the same formula, then you substitute what the acceleration is, then you should get your tension also as 12. Remember, what you do is you always put T is equals to 12 newtons. You always write the magnitude as a positive, and then the negative will always indicate the direction, and the direction here will be left. Okay, very much important to remember that. Guys, we are almost done. Let's see if we have answered all the questions there of question 2.5. That was the last question, I think. Yes, this was the last question of 2.5. Now let's quickly look at your last exam question. Now with this one, we are going to do it together. It says, Passengers sitting on a car observe that they move forward when the car slows down to a stop, and they move backwards when it accelerates from rest. Now 2.2.1 says, use physics laws or principles to explain this observation experienced by the passengers. Then 2.1.2 says, name and explain the physics law or principle that you applied in question 2.2.1. So I quickly want to show you how to answer this type of question, because this one is way different from all the calculations. So the first thing you're going to say is that the passengers in the moving car will continue moving with the same velocity as the car due to inertia. Remember the resistance of the body to stop, right? So due to inertia. And the passengers in a stationary car will remain at rest due to inertia also again. So which law explains inertia? Remember we said it's Newton's first law. What does Newton's first law say? An object will remain in a state of rest or continue moving at constant velocity unless acted upon by an unbalanced force. I hope this one you were able to get it right. Now let's look at 2.2. I think this one you can try to attempt to do it on your own, and let's see how far you can get. So I give you exactly 3 minutes to do this one on your own. Now, welcome back, learners. Let's see if we can do 2.2 together. I hope you have used that time very effectively. 2.2 says, a trailer of mass 700 kg is pulled by a car of mass 1100 along a straight, rough, something tells you something. It means that we have what? We have friction force. Horizontal tow bar, road by means of inextensible rope. The engine of the car applies a force of 9,500 newtons. The car experiences a kinetic friction force of 215.6 newtons between the surface of the road and the tires. The coefficient of kinetic friction for the tow bar road is 0.02. Then 2.2.1 says, draw a labeled free body diagram of all the forces acting on the car. Let's see how I've done it. So what I've done is, on the car, I know that there is a force applied going to the right hand side. This is the force that is applied by the engine of the car, making the car to accelerate to the right hand side. We have the normal force, which is the force that is exerted by the surface of the road to the car. Okay, so then you have the force of gravity or weight, which is also always acting upon objects on earth. Then we have tension, which is experienced by the string. Then we have the kinetic friction force, which opposes the motion of the object. And all of this you get 1 mark each, and then this is equivalent to 5. So you'll get 5 out of 5. Remember that your normal force must be perpendicular to the surface. Now let's quickly go back to the question. 2.2.2 says to us, calculate the tension in the rope. For you to calculate the tension in the rope, you must have collected the data. Okay, you have the mass of the car, you have the mass of the pulled car by the mass of, this is the mass of the car, this is the mass of the trailer. You have friction force, you are given that it is there. You have the applied force of 9,500. You also have the friction force, as I said, is 215.6 newtons, and then you have the coefficient of kinetic friction. So how do you come to your conclusion with this one? The first thing that you are going to do is calculate the friction force that you have there. So of the trailer, you use the formula Fk is equals to UK multiplied by the normal force. You substitute how much the coefficient of kinetic friction is. We're given as 0.02. Multiply it with the 9.8. Remember, the normal force here is equals to Fg. Okay, so Fg is the mass, is equals to mass multiplied by G, which is the mass of the trailer is 700, and the force of, the gravitational acceleration is 9.8. Then you just punch that into your calculator, you get that amount. Then after you are done with that, you will do your Fnet is equals to MA for one object, and Fnet is equals to MA for the car. Then you identify all the forces that are acting across the horizontal axis of the trailer. We have the tension force, we have the friction force that is opposing the motion of the object. We also have the mass of the trailer, and then what you do is to equate T. Remember that you have two unknowns, you will always use simultaneous equations. Again here, your Fnet, you have your 9,500, which is the force applied by the engine. You have the tension, that is what we are looking for rather, and then you have the friction force as you are given as 215,6. Then you have the mass of the car, and then what is left for you is to do your maths and equate T again for the car. Then when you are done, you equate, you say equation 1 is equation 2, or T1 is equals to 2, and then you will have that. You put all of that over there, then you calculate your acceleration. After you found your acceleration, you can go either back to either equation 1 or back to either equation 2 to substitute the acceleration in that formula. Then you'll be able to get your tension as 3,693,2 watt Newton. I hope you guys were able to do this one. This one was a little bit challenging, but I trust that you guys were able to do it together. Okay, guys, thank you so much for joining in today's lesson. My name is still Dimpho Rampora, and thank you so much for joining in.